I can't believe it's already a new year and it's part 4 in this Porsche Carrera 3.2 engine fix. Got some good news today. The heads have come back from the machine shop. So even though the heads look great, I'm going to go through in this video and kind of talk about what a good head rebuild looks like. Clearly this is something I didn't do myself, and I will share who I used to remanufacture these heads. But before I sent them out to be fixed, I actually measured some things like the head thickness from the sealing surface to the cam towers. And I also measured the combustion chamber volume. In addition to that, I measured like some of the valve guide wear and valve guide clearance, which was way out of spec, which that part's been corrected now. But I'm gonna go ahead and take a look at this 5-angle valve job that they put on these heads, because that is going to increase flow and hopefully increase performance. So to measure the volume of this combustion chamber, we need to put the spark plug in it. And then I have this clear plastic disc, and it's pretty thick, pretty stiff. It's gonna go right here in place of the cylinder. It fits, pretty tightly in there. And I'm using this burette to measure how much liquid goes in the head. Once we get all the air out and it's full of liquid all the way up to that plate, we'll know exactly what the volume of the combustion chamber is, because this is a graduated scale on there. Before these went out to machine, I did clean all the carbon off one head and measured 91.4. So we're looking to get something real similar to that. So the liquid that I'm using is a mixture of isopropyl alcohol and Windex. The Windex just basically is the same thing. It just adds a little bit of color to the liquid so we can see where the liquid is and where the air is. So I just fill this all the way up to 0 is at the top, 50 is at the bottom. So we'll want to make sure we're doing 50. This is showing over the line of 50. So I'll just let a little bit out. We want to make sure the entire thing all the way to the tip is full. So with this whole thing being full, we lower it down to where it's 0. See there, it's how it's 0. Each drop is like roughly 1/10 of a cc. So now that we know there's 50 sitting in the head, we're gonna add another 50, and then we'll count off how much is left. And then I have this tacky grease, red grease. I'm just gonna put a little bit on the perimeter so none of the liquid will seep out. Perfect. So right there, it's starting to make contact with the top of the plate. All of this is air. And I'm going to go ahead and rotate the head or the plate so that the vent is on this side. So we're just left with the 2 small bubbles. And if I just manipulate this plate a little bit, try to get those to move around. That's it. All the air is gone, and they're even with the bottom, both of those holes. Let me show you up close. I don't see any area where the liquid has come out the perimeter. And I don't see it coming out this is the intake. Before it was just pouring out of here. So the valves are creating a seal. It's called the meniscus. You read the bottom of the happy face. And when this is perfectly, perpendicular, I'm getting exactly 41. So when I lift this plate off, the liquid kind of goes everywhere, but that's okay. Just gonna pour it back into the bottle and we'll measure one more head. I don't think this head's gonna be any different because I know when they set up the machine, they do all the valve depths the same. But just for fun, I'm gonna measure one more head and then assuming they agree, I'm going to leave it done. 91 is a great number. Just like that. Perfect. Couple taps to see if there's anything coming out of that spark plug hole. Sometimes I'll put my fingers on this and really rotate around to see if there's any bubbles in the spark plug, but I think we're good on that measurement. Could fill more liquid, but it's just gonna rise up in the hole there. Right now the liquid is right there at the bottom of those holes. So the number I'm getting is 41.1. It's 91 versus 91.1. It's very, very close between heads. So I trust the machine shop when they set these up, they are all gonna be the same. I don't see one particular valve sitting lower than the others, so everything here is good to go. I think the factory number when these heads are brand new is like 90.5. So typically what happens when they machine the heads is the valve seats get cut, the valves get lower into the head here, and that just allows for more combustion volume. So to counteract that, they machine this outer ring, and that effectively removes volume from the combustion chamber. Imagine that plate getting closer to the valves or the pistons getting closer to the valves. So that increases compression ratio. Sinking the valves too low decreases compression ratio. So this machine shop did a great job at managing the volume to be almost what the heads would be like brand new. That's what you want. Now because this outer ring is machined, we need to make sure that it's not machined too far or it's not unequal. So every head has to have a maintained distance between the sealing surface and the surface where the cam towers go on. If this is machined too deep or not machined equally, then the cam towers have nowhere to mount. They're going to be at different heights, and that's just going to bend the cam tower. It's disaster if these are not in the right heights. Now what I'm doing, I have this micrometer that's accurate to 4 places, at least in inches. This one unfortunately does only measure in inches, but I'm measuring the height from kind of this surface right here to this surface and comparing it to what it was before. And I'm also going to compare each of the heads to see how much they vary. If I hold this just like that and I'm wiggling it around to get the best fit, and this has a little ratcheting feature on there, so you can't over tighten it. It just measures the number. Okay, same measurement, just have the head oriented so I can get a better view of these numbers here. Now it looks like there's a little bit of a taper in the way the head's machined. So we got to line it up in the same place every time we take a measurement. So I'm going right at the junction where it goes to the combustion chamber. And it's 3.3231. That's inches. This one is 3.323, and then we add this number here, which is 5. Interesting thing is that the new value for the thickness, you know, this thickness here where I measured with the micrometer, depending where you measure it, it's still really close. 3.323 and a 1, which is the 1/10,000ths, or 3.3235, which is 4/10,000ths discrepancy between the intake and exhaust. The number I measured before I took them to the machine shop was 3.3278. So if you subtract those two, that means the machine shop took off 0.0043 from this surface right here. And they did so in a very even way. So I used the date code and this circle with the number in it to distinguish where these heads came from. So this 586 head was on number 2. So I'm writing the new dimension next to the cylinder head number. I'm going to go ahead and measure all 6 heads, and depending on what the variability is on the engine or the cylinder heights, I may move heads around to get the best level fit for the cam towers. These are the new heights after machining. So they're all pretty close. So most of them vary in the 10,000ths place. I will group these probably in the cylinders 4, 5, and 6 will be the bigger numbers, and then cylinders 1, 2, and 3 will be the smaller numbers. That way there, the tolerance stacks up in the right way. You don't want to put a high and low right next to each other because that could put extra stress on the cam tower. Porsche groups their cylinder heights by 0.025 millimeter increments. These are all within 0.025 already. So there's no, I'm just gonna try to, like I said, get the best overall average fit. If you saw in the previous episodes, this is a VW valve spring compressor that I've kind of modified to work with Porsche heads. So let me just make sure the end of this is clean, and then we'll get started. There's one of the keepers. There's 2. These are not directional, but I'm just going to put them back in the same way they came. There's 4 here. So one more. I'll try my extra strong magnet. Yeah. And I don't think this really matters, but I'm going to pull this little spring off the valve stem seal. Just slide that off. So that way there, when the valve comes out, it doesn't really tear the seal. It's going to put a lot less pressure on the seal as it goes through those little bumps. So we'll put that back on in a second. But here is the valve. It looks like these have been lapped in by hand. You can see it's contacting the seat right at the very edge of the valve, which is good. And I don't know for sure, but it looks like the backs of this valve here have been resurfaced. So it's a very nice transition as air, flows through here and into the combustion chamber. You want it to have a nice smooth radius here. So the transition between this valve surface and the back of the valve is pretty nice. Nice curve there so the air can flow over it. And then the real trick is done here on the seat. So we'll look at the different angles on this because there's quite a bit of a chamfer on there that really allows the air to funnel out. So when I put my finger over there, there's no sharp edges. It's almost like it's one continuous radius, but it's not. It's actually 5 different angles linked together. Let me show you. This is going to be hard to see on camera, but I'm just going to use my straight edge and try to count the different surfaces. Considered 1, and then that would be 2, another band there, 3, 4, 5 is this last one. And now I'm taking a look at the diameter of the valves. These look like they've been resurfaced too. So let's zero this out. And I'll do this in millimeters for you guys. I'm gonna go with 8.96. And here's a look at the new valve guide. And I don't know if you can see through there, but the finish on the valve guide is absolutely like a mirror. It's a really nice finish on the inside of there. It has a little bit of oil on it, but it's pretty nice. And these are not the Porsche valve guides. These, he told me they come from SSF, and I don't know who, SSF is a distributor, so I don't know who the maker is. I think it's Canyon. So just like in the previous video, I am using this small hole gauge down inside the hole, and then I pop it out and measure it with this. And this gives me the clearance. The clearance is what's most important. 8.960. So this gives me 0.03 millimeters clearance. That's where it hits the seal. So it's pretty tight. This is the Dempsey book, which pulls all the information out of the factory manual anyways. But the intake clearance should be 0.03, which is what I have, to 0.057. So it's on the tighter side of the spec, which as long as they don't seize up, I think it's great. They're gonna have a long life. Plus, like I said, this is a more modern material that is proven to work with this clearance. So I trust that this is done correctly. Actually pretty happy with that. Installed valve height A for this year on the intake should be 46 millimeters, plus minus 0.3. Just make sure the valve is seated. We just go right down like that. 45.93, which is very close to 46. The amount of shims here is really determined by how much spring pressure you want. And that is something that he set up for me, and I'm gonna take his word for that one because I don't have a way to verify the spring. Basically, when you compress the spring, and I can move it with my fingers, but when it's at a certain height, when it's at the maximum lift, I think you want around, it's like 80 pounds of spring pressure. So what you have to do to measure that is you have to compress it to a known height, measure how much force is used to compress it, and then that's how you get the amount of shims that you need to create that force. This is what prevents the valves from floating at high RPM. But this is not a high RPM engine. It has a rev limiter of 6,500 factory Motronic. So this spring stack is gonna work just fine for the stock engine. Slide it out. Boop, boop, boop. Same thing. It does not feel loose. It feels amazing. So slide that out. Take some measurements here too. You can see the lapping area on the valve is in a good spot. It's at the edge of the valve, which means the valve, it's using the full diameter of the valve, which is good for airflow. So these guides have a little bit more of a taper to them. You can feel it get tighter as it goes down deeper into the head. So let's see what this number is. 640 millimeters. So the book says 0.050 plus minus 0.077. So 0.05 is right in between what I have. That's the target. So it's a little bit tight in the center of the head where it has the casting, and it's a little bit looser here on the end. When the valve goes in, you can see it kind of falls on its own until it hits the seal. 45.97, so right at 46. And it looks like these the ends of these have been resurfaced. They look very shiny. No obvious issues. We now know what the clearances are. I assume all the heads are going to be the same here. Doesn't hurt to rotate it, you know, just to make sure that the keepers are well seated. That's it for the inspection of the head. I don't know anything else that I can do other than tell you that I'm very happy with the work they did on these heads. So let me tell you who did them. The heads were done by Sheldon at S-Tec. They are in Santa Ana, or Orange? I think Orange, but it's a great machine shop. They do work on all engines. The owner, Sheldon, he has a Porsche. He does lots of Porsche work, but they also do like Maserati, Ferrari, some of the Japanese stuff. They basically are a full service machine shop. They got all the best tools. The service that I paid for was $1,200 and they did an amazing job. I think it was less than 2 weeks they got these back to me, and that was over the holidays. I'm gonna switch gears now to the engine. When I took the heads off, there was lots of loose carbon here on the pistons. This kind of stuff is, you know, not something we want to keep in the engine. So if at all possible, we want to dissolve this carbon and get it out of the engine. So I have the cylinders secured with these sleeves and nuts on top. So we're not going to remove the cylinders. We're trying to maintain the seal between the cylinder and the case. That's what these nuts are doing. They're not torqued super tight, but it's just got a little pressure on the cylinders. Berryman's dissolves carbon. And this is kind of, you know, what it looks like. It's a pretty strong mixture. So I am just brushing it here on the pistons and just letting it soak, because this takes time. Like you would soak a carburetor in this stuff, but it will dissolve the carbon without this Berryman's running into the engine. So I'm keeping it in a horizontal position. You see, this is some of the stuff that's just laying in there. And I think I'll brush a little bit on the cylinders too. This is where the rings don't go all the way up the bore. So you're seeing carbon build up there too. This one has more carbon buildup than this one does. Then I'm using these barbecue skewers, but you can get a bunch of that gunk off with just soft tools. I don't want to gouge the piston or gouge the cylinder wall. And I wipe it clean with a paper towel. And this is not done in a matter of minutes. This is done in a matter of days. So better just to let the Berryman's kind of slowly do its work than to just go aggressive with wire brushes and stuff. You really don't need to. You basically just need to let the stuff soak and let it work overnight. I also want to measure the heights across all 3 piston cylinders here and compare that to the head heights and select the best combo so we get the most flat surface for the cam tower possible. Now for this height measurement, I'm just using a straight edge, which is a precision ground piece. And then we're just going to lay it right down on top of the cylinders. And it should make contact on all of them at the same time. But the only way to really know is to use either a flashlight or these really fine feeler gauges. So the thinnest feeler gauge that's in here, 0.015 or 0.04 millimeters. And see if there's any areas where it'll go in. Because if it is, that means there's a difference in height. If I tilt the gauge, I can put the piece in and then measure some drag. So it'll go in right there, but not right there. So that means this cylinder is a little bit higher than this one, but not by much. Cylinder number 5 has partial contact. So I'm going to flip the gauge and try these again. So the discrepancy there on the cylinder height is I don't know, I would say, you know, it's tight on one side, 1.5 on the other side. It's about 0.03 millimeters, which is, I think, within the tolerance of the cylinder height grouping. The factory grouped it with increments of like 0.03 or whatever. So I'm not concerned about the cylinder height, but what I can do is I can take the taller of the cylinder heads and reposition them so that it coincides with the shortest cylinder height, if that makes sense. So it's a little bit of mix and match, trying to get the best overall height using some of the tolerance stack up like I talked about. I've also got a little bit done on some cleanup stuff, plus I got the plated parts back. More gold parts have been completed, so these are all the clamps, the fuel fittings, which I need to take over to get to the hose shop to be reinstalled. Connectors, this is the main pulley, fuel rails, fuel lines, lots of little brackets for the intake system. So these are all highly visible parts that will make this engine sort of look as good as it's gonna run. Next week should be assembly. So thank you again for watching this. This is part 4 of the Porsche 911 engine kind of top end rebuild series.